Welcome to a short video on the calculation of X-bar, or average, and standard deviation. Now in finance, we measure standalone risk with X-bar or mu if it's for population averages, and we use standard deviation or sigma for population's measure of dispersion. Now the reason we do this is investors like return and dislike risk. Therefore, we like to increase return while lowering risk. On your computer screen, you should see three columns of data. The first two are FICO scores, credit scores, and the third is a stock return percentage. And now I'm going to go ahead and calculate its average, X-bar. I'm going to populate the cell right here, and I'm going to go ahead and use statistics and find average. And I'm going to grab these FICO scores here, and I can see the average is 618. Now I've already calculated it by hand here, and you can see all it is the we add up each of the FICO scores and then divide by the number of FICO scores, which were 5. Now I'll come back over here, I'm going to grab the fill bar, I'm going to pull it across, and it's going to calculate this FICO score as well as this stock return. So this FICO score in the middle is a little higher, average, 699.8, and then the stock return shows me it's 13.2%. Those are their averages. Next, let's go ahead and calculate, instead of X-bar, let's do variance. Now here's the formula for variance. The variance is nothing more than each of the variables. I subtract the X-bar average from each of the variables, then square it, and then divide that number by n minus 1. In this case, what is n minus 1? Well, there's 5 scores, so 5 minus 1 will be 4. We do this since it's not a population but just a sample. Now I'm going to go ahead and do it with Excel, formulas, functions, and statistics. I have to go find variance, and here it is here. So I'm going to go ahead and go and capture this value, this value, this value, this value, and the fifth value, and hit OK. And it's 9,670. Again, I've already calculated the variance here as well. If we take a look up here, you see all I've done was I subtract the X-bar average from each of the data points. I square it, add them up, and divide by 4, which is 5 minus 1, and I get this 9,670. Now the variance is not in the same units, so it's a very difficult number to understand. It is the calculation or management of dispersion. So let's go ahead and put it into a number that makes sense, standard deviation. But first, before we do this, go ahead and pull this across, and now I have the variance for all 3 data points. Finally, let's do the standard deviation. Formulas, more functions, statistics, standard deviation. Here it is, and I'm going to go ahead and delete this and grab each number. 1, 2, 3, 4, and 5. Hit OK, and now I have the standard deviation. I'm going to grab the fill bar, pull it across, and have all 3 of them done. And I'm going to go ahead over here. You see I calculated it by hand, and it's nothing more than the square root of the variance. So now, by taking the square root of the variance, we put it back into numbers that are the same numbers of our original FICO scores. So we can see that the first set of FICO scores have a greater dispersion, and it was measured with a variance. And then finally, with the standard deviation, we see that the average is 618 with a standard deviation of 98.34. On the second column, we have a higher average and a lower standard deviation. And what we would do in this case is the first column would have to, if they had to borrow money, would have to pay a higher interest rate because they have a higher risk for default because they have a lower FICO score, higher standard deviation. Now the third column is the stock return. It tells me the average is 13.2% with a standard deviation of approximately 11.78%. If I had a second choice of a stock return that also paid a 13.2% but had a lower standard deviation, I would pick that one instead.